All right, today we're going to pull back the curtain and go under the hood of one of the most influential programming languages ever created. It's a technology that, believe it or not, quietly powers so much of the world around us.
I mean, have you ever really stopped to wonder what's happening deep inside your computer? How does the software you use every single day, your operating system, your favorite games, all those apps, how does it all actually work at the most basic level?
Well, here's the wild part. The foundation for a huge chunk of modern computing isn't some brand new cutting edge tech. Nope. It's a programming language that's been around for over half a century.
And that language is C. It's powerful, it's incredibly fast, and it gets you closer to the bare metal, the actual hardware of the computer, than almost anything else out there.
Okay, so how do you even start to wield this kind of power? Well, like with any good craft, you need a workshop. And in the world of programming, we call that workshop an IDE. An IDE, which stands for Integrated Development Environment, is basically your command center. It brings everything you need all into one place. A spot to write your code, tools to help you find mistakes, and a way to actually run and test your programs. It's the whole shebang. So you've got your workshop all set up. Now what? Well, you don't just jump in and try to build a skyscraper on day one, right? You start with the foundation. You start by solving simple, understandable problems. And in C, the basics are things that probably look pretty familiar, stuff you might have even learned back in math class, calculating the perimeter of a rectangle, finding the area of a triangle, figuring out simple interest. This is how you learn the ropes, you know? You get a feel for the syntax and the logic, one small step at a time. But listen, C is so much more than just a fancy calculator. Its real power, the thing that gives it this legendary status, is its ability to reach deep down into the machine and take direct control. This is exactly why, even today, C is the backbone for operating systems, high-performance game engines, and all those tiny embedded devices where every single bit of memory matters. And this is the key. This is what really sets C apart. See, a lot of modern languages kind of hold your hand, managing the computer's memory for you behind the scenes. C? Nope. C hands you the keys to the car. It lets you tell the computer exactly where to store information and how to get it back. You are in total command. So how does it do this? What's the secret sauce? Well, it all comes down to one of its most famous and, let's be honest, sometimes infamous features: pointers. Now, pointers can sound a little intimidating, but this image breaks it down perfectly. Think of your computer's memory as a massive street with millions and millions of houses. A variable, like the word string, is living inside one of those houses. A pointer doesn't actually hold the word string itself. Instead, it just holds the house number, the address, which is 100 on this diagram. It's just a little note that tells you exactly where to go to find the real data. And check this out. This is what that control looks like in practice. On the one hand, a programmer can set aside memory for some text that they know they'll need to change later on. But on the other hand, they can point to text that's in a totally protected, read-only part of memory. This ensures it can never be changed by accident. That right there, that's direct control in action. But you know what they say about great power, right? When you've got the keys to the entire machine, you can also mess things up royally if you're not careful. That power comes with a whole lot of responsibility. Let's take a classic example, this old function called gets. Its job was simple: get some input from a user. But here was its fatal flaw. It never bothered to check how much space it actually had to work with. So if you had a box that could only fit 10 letters, gets would happily try to stuff 100 letters in there, spilling everything over and overwriting whatever was next to it in memory. That's a buffer overflow, and it's a huge, huge deal. It can crash programs or, even worse, create massive security holes. The function was so dangerous that it was eventually removed from the language standard entirely. So yeah, there are risks, but that raw, low-level power is exactly why C's legacy is so strong. It's the ultimate bridge, the perfect translator between our software ideas and the physical hardware itself. It's the language that lets software talk directly to silicon. Just look at this flow here. Your program doesn't need to get bogged down in the nitty-gritty details of how to talk to the operating system or the actual physical disk drive. Nah, instead it just uses a simple function from the C standard library. And that library acts like a universal translator, handling all that messy, complex stuff for you. And this library is what makes C so incredibly practical.
It gives you simplicity by hiding all those gnarly operating system details. It gives you portability, so your code can run on Windows, Mac, or Linux without a ton of rewriting. And it guarantees a standard, predictable way of doing things, which just makes a developer's life so much easier. When you really boil it all down, it comes back to this one core idea. C doesn't just let you write a program, it literally gives you the keys to the machine itself, from its individual memory addresses all the way down to its physical hard disk.
It's a language that puts immense trust in the programmer, offering unparalleled control and performance in return. So the only question left is, what are you going to build with that power?